All right, today we're going to talk about section 5.4, factoring polynomials completely from Algebra 2. I'm not going to talk about solving them because remember that's in a different video. All you do is you set each piece equal to 0. So let's go back and let's remember how to do some factoring quick. So first thing I always need to look for is there a greatest common factor in my problem? If I look at this first problem, 8x squared plus 20x, well first we know we can take out a 4 because of the 8 and the 20. Then we need to look at our x squared and x, and we can also pull out an x, which leaves us with 2x plus 5 on the inside. So remember, to figure out to solve this, if I set this equal to 0, we would set 4x equals to 0, equal to 0, and we'd set 2x plus 5 equal to 0 to get x equals 0, or x equals negative 5 halves would be my solution to that problem. I'm not going to show you how to do those anymore, just the solving. I'm just going to talk about the factoring part. All right, n squared minus 4x minus 60. Remember, what we need to do is multiply our a times our c. We get negative 60. So what numbers multiply to get negative 60 but add to get you negative 4x? You could do the box method. You could do factor by grouping. Whatever you need to do to remember. But if we went and we factored this, we would get n minus 10 times n plus 6, and that would be our factored version. Remember, if you do the box method, you would make your box and multiply them. So I'm going to do the box quick to show you how to do that one. So on the top, you put your n squared, put your negative 60 in the bottom left. What multiplies to get you negative 60, but adds to get you negative 4? Well, we'd get negative 10x and 6n, not x. Pull out your greatest common factors, and then there you go. That's how we get our factored version. All right, this next one I'm going to show you guys the grouping, the factor by grouping. Again, remember we need to multiply our 2 times our negative 20. So it needs to multiply to get you negative 40, but add to get you negative 3. So to do the factor by grouping, we're going to make this 2x squared minus 8x plus 5x minus 20, and then we factor each piece, or we group each piece and pull out the greatest common factor of those. So we're going to end up with 2x getting pulled out from the first part, so we get x minus 4, and then we're going to pull out plus 5, a positive 5, to get x minus 4 again, and then we pull those out and we get x minus 4 times 2x plus 5. Obviously you can go the other way, so it could be 2x plus 5 times x minus 4 as well. All right, you might also have to take out a greatest common factor and then factor, so we'll have x times x squared plus 2x minus 15. Now we need to see what multiplies to get you negative 15 but adds to get you 2x. So it's going to end up being x times x plus 5, x minus 3. All right. So I'm going to let you guys try that one on your own, and I'm going to put up the answer here in 1 second. All right, that's the furthest you guys can go right now, just pulling out the greatest common factor of 9m squared. We'll talk more about those kind of bigger degree problems in a little bit here. First, let's take a refresher on how we would factor out this problem here. If you look at, we can factor by grouping. So we have y cubed minus 7y squared plus 4y squared minus 28. So what we can do is we can look at each piece and pull out a greatest common factor, see if we can get a common thing inside the parentheses. So that first part, I'm going to pull out a y squared, leaving y minus 7 on the inside. Now we want to end up with y on the inside for this, y minus 7 on the inside for that piece. So what can I pull out? We'll pull out a positive 4 to get y minus 7. Now if you look, we have common terms right there that we can pull out front to be y minus 7 out on the front. And these little pieces are left, leaving y squared plus 4 to be our other piece of our factored form. So let's use the same kind of thinking for these two problems here. See if we can do the same kind of thing. So again, factoring by grouping, let's look at each piece of these separately. So I'm going to take pairs. What can I take out of 4c cubed plus 8c squared? Well, I can pull out a 4c squared from each of those, leaving c plus 2. Now we want that same c plus 2 to be left on the inside of our parentheses. So does that work if I take out, what can I take out first of negative 9c minus 18? Well, I can pull out a negative 9, and that indeed does leave c plus 2. Again, pull out our pieces, pull this piece out to leave c plus 2 out front, and what's left on the other piece of my factored form is 4c squared minus 9. Try these two. I want you guys to try on your own, and I'll put up the answers in a second. All right, here's the answers I got for those last two. Check your guys' answers. Let me know if you have any questions. I do want to go back, though, because we are fully simplifying our problems here. So what I need to look at is, do I fully factor these? That first one, it doesn't have a squared left, so we know we fully factored it. This piece right here, well, that one's really not fully factored because we can factor that further. Why can we factor that further? Well, I'll come back to that in 1 second because I want you guys to remember our perfect squares, our difference of perfect squares. Remember, difference of perfect squares. What that means is x squared, well, that's a squared, and negative 36 is a squared as well, 6 times 6. So remember, when we have a difference of squares here, really we can make this x plus 6, x minus 6. Because if I factor it out, that'll work out to be that way. If we have a sum of squares, well, our fully factored version still stays the same as what it originally was. That's our final answer. We can't go any further. So let's show you another example here quick with the 9 squared minus 100. 9 is a perfect square. X squared is a perfect square. So really our first part is going to be 3x. And our second part is going to be, well, what squared gets you 10 or 100? It's going to be 10. So it's going to be 3x plus 10, 3x minus 10. So really what your form is looking at here, it's really 3x squared minus 10 squared. We put the 3 in our first part, and I put the 10 in the second piece. So again, let's look at this next part here. What can I pull out, or what can I factor this out? First thing I can do is, I have y's that I can pull out, greatest common factors. Y cubed, so this would be 2y squared minus, whoops, I can also pull out a 2, can't I? So it'd be 2y cubed times y squared minus 9. Now we can look, and really, this y squared minus 9 is the same thing as y squared minus 3 squared. So, in turn, that ends up becoming, we're going to bring down that 2y again, 2y cubed, and we're going to have our difference of squared, so y plus 3, y minus 3. That's our fully factored version. So now what I want you guys to do is I want you to look at this problem that we didn't finish, that I'm telling you we didn't finish, and I want you to also look at the two problems that you guys didn't see if you guys can expand those any further, or sorry, factor those any further. So, I'm telling you that the first one is not fully factored, the other two might be fully factored. I'll put up the answers in 1 second. Alright, circled in the purple there is my new solution, or my fully factored solution to that problem that we originally did. You can see we could go further. The last two that you guys did on your own, we can't go any further. And the reason is that second piece of the factor is a sum of squares. It's not a difference of squares. So we can't go any further. Alright, now that we've talked about the difference of squares and the sum of squares, which we can't simplify anymore, we're going to talk about perfect cubes. The difference and the sum of perfect cubes. So, rules to know is we have a cubed minus b cubed, and what we can factor that out to is a minus b, the quantity a minus b, times the quantity a squared plus ab plus b squared. And if we have a sum of perfect cubes, a cubed plus b cubed, what we can factor that out to be is a plus b times the quantity a squared minus ab plus b squared. Now you guys can go online, find proofs of why these work, but I'm telling you right now they work, and you're going to need to know those equations. So if you need to pause to write those down, do that now. Because we're going to go and do some examples. So the first thing we have to do is we have to look, are these perfect cubes? Is there a way I can write this out to be something cubed minus, it's a difference of cubes because it's minus something cubed. Well, the easy one there is, well, 1 is really 1 cubed, 1 times 1 times 1, right? And we know to get the x cubed, we need to multiply by x. Now the tough part. What cubed gets you 64? We have two options of doing this. You could do the cube root on your calculator, or you could do the factor tree and figure out what multiplies to get that, or what numbers get me there. So I'm going to do the factor tree quick for you guys. 2, 4, 2, 2. And remember, we need pairs of 3, groups of 3, not pairs, groups of 3. So we have 3 2's there, and we also have 3 2's there. That means that 4 cubed gets me 64. So really, this is 4x cubed, the quantity 4x cubed minus the quantity 1 cubed. So now we go back to our difference of cubes equation that tells us that a cubed minus b cubed equals the quantity a minus b times a squared plus ab plus b squared. Well, if we look over here, what we have, this 4x is actually going to be our a, and this 1 is going to be our b. So all we have to do is plug that into our problem over there. So we're going to get 4x minus 1 times 4x squared plus 4x times 1 plus 1 squared. Now we just have to simplify that. So we'll have 4x minus 1 times 16x squared plus 4x plus 1. Now we have to see, can we simplify this anymore? So what multiplies to get you 16 but adds to get you 4? There's nothing. So this right here is our fully simplified, fully factored version of that difference of cubes. All right, I'm going to show you guys a sum of cubes. Again, let's rewrite this so it's cubed, and this is going to be 2x cubed plus 3 cubed. So our a in this problem is 2x, and our b is 3. So remembering that a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So let's fill in our pieces now. So we're going to fill in the 2x there. So we have 2x plus 3 times 2x squared minus 2x times 3 plus 3 squared. Simplify that piece there. 2x plus 3 times 4x squared minus 6x plus 9. So now we need to see, are there any numbers that multiply to positive 36 but add to get you negative 6? Well, if we're multiplying to get a positive and we're adding to get a negative, we know they both need to get negative. We're not going to be able to do that. So this is our final answer right there. All right, I'm going to let you guys do these last 3 on your own. I want you guys to check them, and I'll put up the answers in a second so you guys can check your work. All right, here are the solutions. I want you guys to look at this first problem because a lot of you guys are going to stop when you get to this point here. Don't forget, you need to look at that second piece and see if you can factor that part anymore. And that one you can factor it some more. Some teachers will be okay if you stop at this point, but I personally think you should simplify it the most and put those, or simplify it the furthest you can go and put those together because it's really a plus 2 squared. So that's why I got that as my final answer. Then these last 2 here, you can't go any further, so you guys will be fine if you stop there. This first problem, a lot of you guys are going to try to do the difference of cubes, and you're going to realize 192 isn't a perfect cube, nor is 3. That's why you need to always, always, always first look at your greatest common factor. Can I pull out a greatest common factor? All right, that's all I'm going to talk about on this video. Let me know if you guys have any questions, rewatch anything you need to rewatch, and pause where you need to pause.